So guys, welcome to J Cloud, and this is your cloud mentor Gaurish. Today we are dealing with Max, and the portion is from the first year. It is the fundamentals of relations and functions. So let's move on. And the objectives of this lecture are: we are going to study ordered pair, Cartesian product, relations, different types of relations, inverse relation, composition of relations, functions and mappings, classification of functions, algebraic functions, and inverse of function, and also composition of the function. Okay, so these are the things we are going to deal with in this video. So move on. In mathematics, we come across many relations such as number m is less than n, line L is parallel to line m. In all these, a relation involves pair of objects in certain order. Concept of function plays very important role in mathematics since it captures the idea of a mathematically precise correspondence between one quantity with the other. So let's go in detail. Two elements A and B listed in a specific order form an ordered pair denoted by denoted by ordered pair AB, which is A comma B in bracket. In an ordered pair AB, A is regarded as the first element and B is the second element. It is evident from the definition that ordered pair AB is not equal to ordered pair BA. Okay. In ordered pair AB, the first element is A and second element is B, and the ordered pair AB is not equal to ordered pair BA. And also, if A and B equal to A and B is equal to ordered pair AB equal to ordered pair CD, if and only if A equal to C and B equal to D. Okay, so that is we need to talk about the equality of ordered pair. Here, equality of ordered pair. So two ordered pair A1 B1 ordered pair A1 B1 and ordered pair A2 B2 ordered pair A2 B2 are equal if and only if what we have talked already. If and only if A1 equal to A2, that is first elements are equal and second elements are equal, that is A1 equal to A2 and B1 that is equal to B1 equal to B2. So that's the definition. That is A1 ordered pair A1 B1 ordered pair A1 B1 is equal to ordered pair A2 B2 ordered pair A2 B2. Okay, so which implies A1 equal to A2 and B1 equal to B2. Okay, and thus it is evident from the definition that ordered pair 1 2 is not equal to ordered pair 2 1, and ordered pair 1 1 is also not equal to ordered pair 2 2. And let's go for a simple problem. That is, if x by 3 plus 1 equal to x by ordered pair x by 3 plus 1 y minus 2 by 3 equal to ordered pair 5 by 3 1 by 3. So here we can use the equality of the ordered pair, that is x plus 1. Here we can write it as x by 3 plus 1 must be equal to 5 by 3, right? And y minus 2 by 3 must be equal to 1 by 3. So x by 3 will be equal to 5 by 3 minus 1 1 by 1. Okay, 1 is 1 by 1, and y here equal to 1 by 3 plus 2 by 3, 1 by 3 plus 2 by 3, and we will get x by 3 as x by 3 will be equal to 5 minus 3 by 3, that is 2 by 3, 2 by 3, and y here we get it as 3 by 3, 3 by 3, that is 1. So here x here will be equal to 2 and y equal to 1. We got x and y. So next topic, that is the Cartesian product. What do you mean by Cartesian product? Let A and B be two non-empty sets. The Cartesian product of A and B is denoted by A cross B and is defined as the set of all ordered pair AB, where A is element of all element of set of all ordered pair AB, such that x element of x element of first set A and y element of B element of, I mean here we are not taken x and y, here it is A and here it is B. Okay, B element of set B, that is a condition here. Symbolically A cross B, I can otherwise write here more clearly, that is ordered pair AB such that A element of A and B element of B. This is the definition. If there are three sets A, B and C, and A element of A, the small letter A is element of A, and small letter B element of B, and C element of C, then we form an ordered pair or ordered triplet, that is ABC. ABC. The set of all ordered triplets is called the Cartesian product of three sets A, B, C. Capital A, B, C. It is the ordered triplet of Cartesian form of the ordered triplets A, B, C. Okay, and that is, we can write it as A cross B cross C, A cross B cross C, that is equal to set of A, B, C such that A element of A, B element of B, and C element of C. So this is the definition. An ordered pair and ordered triplet are also called two tuple and three tuple. Ordered pair is known as ordered pair. Ordered pair is known as two tuple, and while ordered triplet is called three tuple. Okay, that's for information respectively. And for example, let A equal to for example, let A equal to set 1 2 3 1 2 3, and set B equal to set XY. So then A cross B will be equal to 1, let 1 crosses to X, that is 1x, relation is 1x 1 with y, that is 1y, and the next element 2 with the x, that is 2x, and 2 with y, that is 2y. Okay, then the next element 3 with x here, that is 3x, and the 3 with, that is here the first element must be the element of the first set here, that is 1 is the set of 1 is in the set of A, here 2 is the set of A, and like that the second element must be of the B. So 3x 3y and that's all. Okay, and now B cross A will be opposite to that. The first elements must be from the B, that is x1, x1, x2, x3, x3, and y1, y1, y2, and y3. So that was that. And now note that if A is not equal to if A is not equal to if A is not equal to B, then A cross B is not equal to B cross A. Okay, and if A has P elements, A has P elements. This N of A equal to P, and N of B equal to, let it be Q, equal to Q. Then A cross B has PQ elements. Then A cross B, N of A cross B will be equal to PQ. So here we got, there are 3 in the A and 2 in B. So 3 multiplied by 2, that will be 6. So here it is 1, 2, 3, 4, 5, 6, 6 elements. So that's correct. And now the third point, if A is a null set, if A is equal to null set and B is equal to null set, then A cross B will be surely null set. Null set. Okay. And the fourth point, Cartesian product of n sets A1, A2, A1, A2, A2, A3, etc. An is the set of all n tuples, that is A1, set is A1, A2, A3, A3, etc. An this is AI, this AI element of A. It's I equal to 1, 2, 3, etc. up to n, and is denoted by A1 cross, A1 cross, A2 cross, A2 cross, etc. up to an, or it is okay. That's all. And now now let's we need to talk about some properties of the Cartesian product. It is, they are the properties of properties. So if A, B, and C are 3 sets, then we can write A cross B union C. A cross B union C will be equal to A cross B, A cross B union A cross C. It's a property, and the sub property is that if A cross B intersection C, A cross B intersection C will be equal to A cross B intersection A cross C. So that's the property. And the second property is that A cross B minus C, A cross B minus C will be equal to A cross B minus A cross C, minus A cross C. Okay, A cross B minus A cross C. And the third point or third property is that A cross B equal to A cross B equal to B cross A implies and implied by A equal to B. Okay, and the fourth point here to be noted is that if A is a subset of B, A is a subset of B, which implies A cross A cross A is a subset of A cross B intersection B cross A, intersection B cross A. And fifth point, if A is if same A if A is the subset of B, then we can also write, which implies A cross C is a subset of, I mean A cross C. A cross C is a subset of B cross C. Okay, and the sixth point, if A is a subset of B, if A is a subset of B, and C is a subset of D, C is a subset of D, which implies A cross C is a subset of B cross D. A cross C is a subset of B cross D. And seventh point is that if A cross B intersection C cross D is equal to, or we can write A cross B intersection C cross D as A intersection C cross B intersection D. Okay, and now the eighth point is that A cross B complement union C complement, the whole complement, will be equal to A cross B intersection A cross C. And the ninth point, or the ninth property, will be A cross B complement intersection C complement, the whole complement will be equal to A cross B union A cross C. So that's the property. And the last property is that if A and B have n common elements, then A cross B and B cross A have or will have n square elements. That is n into n, that is n square common elements. And that's it. And we now need to go for the question. If set A has 3 elements and set B equal to 3, 4, 5, then find the number of elements in A cross B. That is, you know that P here will be equal to 3 and Q is equal to 3. So PQ, that is the number of elements in A cross B, that will be equal to 3 by 3 multiplied by 3, that's equal to 9. So answer is B. And now next question, if A, B and C are any 3 sets, then A cross B union C is equal to, you know that A cross B union A cross C, that which is that A cross B union A cross C, that is the option A is the right answer here. It's from the properties. So that's it. So now let's go with the relations. Let A and B be two non-empty sets. Then a relation R from A to B is a subset of A cross B. We know what is A cross B, and the relation R from A to B is always a subset of A cross B. And thus R is a relation from A to B, which implies R is a relation from A to B which implies R is a subset of A cross B. R is a subset of A cross B. And if R is a relation from a non-empty set A to a non-empty set B, and if the ordered pair AB element of R, then we write A is ARB, and which is read as A is related to B by the relation R. A is related to the B by the relation R. And if A ordered pair AB is not an element of R, then we write it as A not related to B. That is A R B and a cross over that, and it is read as A is not related to B by the relation R. For example, if R is a relation from the set A equal to set 1 2 3, and B equal to set 149, defined as let it be the square or square root. Okay, I mean, in quotation, the relation is square. Okay, so here we know that the one is related to this one, that is the square of this one is this one in the set B, and so we can write it as 1R1, that is here 1 is related to the 1, and also 2R4, that is 2 related to 4, that is the square of the 2 is 4, and also we can write 3 related to 9, 3R9. Okay, so this relation will be the set, or the relation will be equal to the ordered pair 1 1, ordered pair 2 4, and the ordered pair 3 9. Okay, I hope you understood that. And now let's talk about the domain and range of relations. Let R be a relation from A to B. The domain of R is a set of all those elements A element of A. Domain, okay, domain of elements. Relation is the set of A element of A, such that the ordered pair AB is element of the relation R. For some B element of B also. Okay, and therefore domain can be defined by domain of R equal to set of all A element of A such that ordered pair AB element of R for all B element of B. So that's the definition. And range, okay. Therefore the range of R is the set of all those elements B element of B, such that AB, ordered pair AB is element of R for some A element of A. So we can define that by the same method, that is range of R equal to set of B element of B element of B such that AB AB element of R for all A element of A. So that's the definition of range. Here, the set B is called the codomain of R. Here, the set B is the codomain of R. And for example, let A equal to set of 1, 2, 3, set of 1, 2, 3, and B equal to set of 3, 5, 6, 3, 5, 6. Then let A is related to RB, which implies A is less than B. A is less than B. This is a relation. So R equal to, then R can be written as ordered pair A must be less than B. So 1, if you take 1, then we can take any of them. The A must be less than B. Okay. So the relation R, probably you will think that we can write ordered pair 1, 3. Ordered pair 1, 3. But we can't do that because the 3 is element of both A and B, so we must remove that. Okay, so we must not include that 3 in the place of B. Okay, so the ordered pair, the answer is ordered pair 1, 5. The relation is ordered pair 1, 5, 1, 5, and 1, 6. We can write 1, 6, and taking 2 is related to 2 can be related to 5 and 6, 2, 5, and 2, 6, 2, 6, and so taking 3 we can write 3, 5, 3, 5, and also 3, 6. So this is the relation here. So now we need to write the domain and range. Domain will be the A element of A. That is the first element of the ordered pair. First element of the ordered pair. That is the, who is the first elements? That is the 1, 2, and 3. So domain will be equal to 1, 2, and 3. Set 1, 2, and 3. I hope you got that. That is the first elements 1, 2, 3. And next we need to write the codomain or the range. Range will be the second elements, that is B element of B. Range equal to B element of B, that is the second elements, that is 5 and 6. So range is 5 and 6. And now what is the codomain of R? Codomain of R is the set B itself, the second set itself. So this is the codomain. So codomain is codomain equal to set of 3, 5, 6, or it is equal to B. So that is everything. And now let A and B, not that, let A and B to non-empty set, non-empty finite sets having P and Q elements, That is let n of A equal to P and n of B equal to Q, respectively. Then total number of relations possible from A to B is equal to total number of relations, that will be equal to 2 raised to PQ. Okay, 2 raised to total number of relations, that is 2 raised to PQ. And now let's go for a problem. So problem is that, and if find the domain and range of the relation R defined by R equal to x plus 5 such that, ordered pair x plus 5 such that x element of the set 0 1 2 3 and so on. So the relation will be, the relation here will be that simply if you take the 0, first element 0, then the next element must be uh, 5 greater than that. So the ordered pair 0 0 plus 5, that is 6, and second, that is 1, then 1 plus 5, that is 6, 1 6, 1 plus 5, 0 plus 5, that is, sorry, 5, and 1 plus 5, that is 6, and now taking the third, that is 2, then 2 plus 5, that is 7, and taking 3, 3 plus 5, that is 8, and so 4, 4 plus 5, that will be 9, and now taking 5, so 5 plus 5, that is 10. So this is the relation, and the first elements are the range. We need to find here domain and range. So domain will be, those first elements will be the domain, and domain here will be equal to the 0 0, or these ones, 0 1 2 3 4 and 5. Now range will be equal to, the second element. So this here 5 6 7 8 9 and 10. So 5 6, set of 5 6 7 8 9 and 10. So that's it. And now so which is the correct answer? 0 1 2 3, domain is 0 1 2 3 4 5, and this range is this one. So option A is the right answer. So option A is the right answer. And now let's talk about the different types of relation. First one, I need to talk about the void relation. Void relation. Let A be a set and null set phi be a proper subset of A cross A. It follows that the phi is a relation on A which is called the empty or void relation. This phi is the relation which is on A, which is called, or which is known as the empty or void relation. So that was, and now what is the universal relation? Universal relation. Universal relation. Let A be a set and A cross A is a subset of A cross A. And it follows that A cross A is a relation on A which is called universal relation. So this A cross A is called is the relation which is called the universal relation. Now the third one, it is the identity relation. I am not talking more elaborate on the topics, okay? It is not so important for exam, so I'm not talking more about that. And identity relation. So what is that? Relation, not relation. This relation. And now the relation IA, on set A is called an identity relation, and if every element of A is related to itself only, okay, the relation IA on set A is called identity relation if every set or every element, okay, every element of A is related to itself only. Symbolically, the relation can be written as IA equal to set of AA ordered pair AA such that A is element of A. A is element of A. So that's it. It's called an identity relation on A. For example, for example, for example, if A set A equal to set 1, 2, 3, A equal to 1, 2, 3, and then an identity relation on A is given by IA equal to the same 1, 1, 1, 1, 2, 2, and 3, 3. So this is the identity relation. Okay, oh, we got that. And now the next one, the next topic, it is the inverse, not different or the type of relation. It is next topic, inverse relation. Inverse relation. I think okay, inverse relation. If R is a set on, or the if R is a relation on set A, then the relation R inverse, it's R inverse on A defined by R inverse equal to set of all B A ordered pair B A such that AB is ordered pair AB element of R. AB element of R is called an inverse relation to A. In an inverse relation to A, clearly the domain of the inverse, that is R inverse, will be equal to the range of R, will be equal to the range of R, and the same range of R inverse will be the domain of R. Just the inverse domain of R. So for example, let A equal to set of 1, 2, 3, set of 1, 2, 3, and let R equal to set of 1, 2, 1, 2, 2, 2, 2, 2, 3, 1, 3, 2, 3, 2, and that's all. The R being a subset of A cross A, it is a relation on A. The R being a subset of A cross A, it is a relation on A, and clearly 1 is related to 2, and 2 is related to 2, 3 is related to 1, and 3 is related to 2. 3 is related to 2. So domain of R. So domain of R. R equal to set of 1, 2, 3. 1, 2, and 3. And the range will be equal to set of 2, 1. Set of 2, 1. So R inverse will be equal to the just opposite, that is BA, that is 2, 1, 2, 1 ordered pair BA. I have written here ordered pair BA. So just inverse this A and B. So ordered pair 2, 1, ordered pair next one, it will be same, ordered pair 2, 2. Now ordered pair 1, 3, and ordered pair 2, 3. Okay, now the domain of R inverse will be equal to set of ordered pair 2, 1, 2, 2, So sorry, I am writing the relation again. So domain will be the 2 or 1 2 3. Okay, domain will be here the 1 2 not 3, 1 and 2. Domain will be 1 and 2, 1 and 2. And so range will be set of here it is 1 1 2 and 3. So that's the opposite to the domain and range of the set of the relation R. The inverse is opposite to the or the uh, just opposite. Okay, that is range will be set 1 2 3. So let's move to the next question. The relation R defined in A equal to set 1 2 3 by A related to B, I R B. Okay, and if a square modulus of mod a square minus b square is less than or equal to 5, which of the following is false? So this relation is from A to the same set A, so we can write the relation R as R equal to set of 1 is related to 1. That's not uh, contradicting the condition here given here, that is a square minus b square less than or equal to 5. So we can write as 1 1 1 1. So, and one can be related to 2 also, that is 1 2 1 2 and 1 3. They are not contradicting with this relation here, that is a square mod a square minus b square is less than. So here 1 square minus 2 square, that is, will be equal to 3. So we can write this 1 3, we can write this 1 3 because it is against this. And so taking 2 next to 2, I think we can write 2 2 1 2 1. And now 2 can be related to 2 itself, that is 2 square minus 2 square, that will be 0 0 is less than or equal to 5. So 2 2. And now taking 2 with the 3, 2 3 2 square 2 square, that is 4 4 minus 3 square, that is 9 4 minus 9, that will be equal to 5, and that's less than or equal to, so we can write that also, that is 2 3 2 3. And taking 3 3 can be related to 1. Okay, that is 3 square is cannot be related because 3 square it is 9 9 minus 1 will be equal to 8 8 is greater than 5, so we can write that. And 3 related to 1 cannot be, and 3 related to 2, I think we can do that because 3 related to 2, that is 3 square is 9 9 minus 4, that is will be 5, that is equal to 5. So that's a relation. So 3 2 3 2 is a relation, and now 3 3 is also a relation. So this is the relation here. Now the options here are relation 1 1 2 2 3 3 2 1 2 2. So this is the, so first statement is right. We need to take the false statement from this. And the domain and range we can find here. Domain of R will be equal to the first elements, that is domain of R. Domain of R will be equal to set of 1 2 and 3, set of 1 2 and 3. And also the range will be equal to range, so that is the right answer, C is right. And the range will be equal to set of the second elements, that is 1 2 and 3, 1 2 and 3, the same 1 2. Sorry, the range will be, yes, the range will be second elements, that is 1 1 2 and 3, 1 2 and 3. And now we can find the R inverse. R inverse is just the opposite, that is 1 1 1 1 2 1 2 1, and here it is 1 2 1 2, and here 2 2 2 2, here it is 3 2 3 2, and here it is 2 3 2 3 and 3 3. So isn't that same here? That is 1 1 is here, and 2 1 is here, 1 2 is here, and 2 2 is here, 3 2 is here, and 3 3 is also here, 2 3 is also here. So we can we now know that R is equal to R inverse. So the second statement is also right, and the fourth statement is wrong. It is the range of R is equal to the 1 2 3 is equal to 1 2 3. So that's the option. And now let's move to the next topic, that is composition of relation. Composition of relation. Let R is a subset of let R is a subset of A cross B, A cross B, and S is a subset of B cross C, B2 relations. Then composition of set relations R and S denoted by SOR. SOR is a subset of A cross C. Is a subset of A cross C, and is defined by it is defined by AC ordered per AC element of SOR, S composition R, and if and only if B element of B, B element of B, and the statement AB is element of R and BC is element of element of S. For example, A equal to, let A equal to set of 1 2 3 1 2 3, and set B equal to set of A B C and D, and C equal to set of alpha, beta and gamma. Then relation R will be the subset of A cross B, that is equal to 1A, that is equal to 1A 1C 1 related to 1C and 1C and 2D. Suppose 2D 2D and S equal to S is a subset of S will be the subset of A cross C, sorry, B cross C, then the set of A alpha, suppose the set A alpha, this be the relation A alpha, C beta and D, C gamma and D beta, then the composition S composition R will it will be the subset of A cross C, and that will be equal to set of taking the first one, that is 1, and the from the second taking the second element alpha, that is 1, like this, 1 alpha 1 gamma and 2 beta, that is 1 alpha 1 beta and 2 beta, 1 gamma and 2 beta. So that's it. One should be careful in computing the relation ROS. ROS actually SOR starts with the relation R and ROS starts with the S. What is that? ROS or ROS starts with S. Starts with S, while SOR starts with R. Here it was we are finding the SOR, so we started with the R. Started with the R. So that's it. Okay. Don't make the mistakes like that. And now the next topic is the functions or mappings. So we are starting with functions. Let A and B be in two non-empty sets, then a function f from set A to B is rule which associates elements of set A to elements of set B. It is a rule which associates elements of set A to elements of B, such that all elements of set A are associated to elements of set B in unique way. And if the function f associates x element of A to y element of B, then we say that y is the image of the element x and denote it by f of x. What is that? If the function f associate x element of A to a y element of B, then we say that this y is the image of element x and denote it by f of x, and write thus y equal to f of x. The element x is called the pre-image or the inverse image in B. The element x is the pre-image or inverse image in B, and the function is denoted by f from a function is denoted by f from A to B, or like this, an arrow and a f above that arrow. Okay, and note that there may exist some elements in set B which are not the images of any element in set A. And to each and every independent element in A, there corresponds one and only one image in B. Okay, for each and every independent element in A, there corresponds only one and only one image in B. That's the second one thing to be noted. And the third one, every function is a relation, but every relation may or may not be a function. Okay, every function is a relation, but every relation may or may not be a function. And the fourth point, the number of functions from a finite set A into finite set B is equal to n of b, that is number of elements in the set B, the raised to n of a. Number of relations were 2 raised to pq, that is p were the elements of a and q were the elements of q element of b, but the number of functions is n of b, that is number, otherwise in terms of p and q we can write this is q raised to p, which is the number of functions possible from finite set A to finite set B. And the difference between a relation and function. Let's talk about the difference between the relation and function. What is the relation? What is the difference? So let's have a look at that. Geometrically, if we draw a vertical line or the vertical parallel line, geometrically if we draw a vertical parallel line, that is called as VPL, and there is any line which is parallel to y-axis, this x equal to a. Question would be x equal to a. Any line which is parallel to y-axis, that is x equal to a. And then if this line intersects the graph if this line intersects the graph of the expression in more than one point, then the expression is a relation, and else if it intersects at only one point, the expression is a function. For example, let's take some examples of the graph. Okay, there is one graph here and another I am drawing here. It is a circle with the center as origin, or anything. If any circle with any center as any coordinate, that's not a problem here. We are testing these two graphs with the test line. There is a VPL, that is vertical parallel line, which is a line parallel to y-axis having the equation x equal to a. So if that line intersects the graph or the graph of that function at more than 2 points or more than one point, then it is called a relation, and if it intersects only at one point, then it is called uh, a, a function. So let's draw a test line here. So I have drawn a test line which must be parallel. Now no, it is not parallel, but it must be parallel to the y-axis, and this is a test line here, and another one I am drawing here also. We can clearly see that this in this graph, the test line intersects with the graph only at one point, only at this point, and in this graph the test line is intersecting the graph of the function. Graph of the function is this circle, and here the graph of the function is this wave. But here the test line intersects the graph at 2 points, that is here and the here. So this is a relation. Clearly we have proved that this is a relation, the graph of a relation, while this is the graph of a function. So this is how we can choose a relation or function from the graph. So now let's talk about the domain, codomain, and range of a function. We talked about the domain, codomain, and range of a relation. Now we are talking about the that of the function. So domain, codomain, and the range of the function. Let f from a to b, then a is known as the domain of f. A is the domain of f. A is the domain of f, and b is known as the codomain. B is the codomain. B is the codomain of f. Also set f of x equal to, also set f of x f of a equal to set of f of x such that x element of a is known as range of f. Okay, clearly f of a is a proper subset of B. Okay, and for example let a equal to set 1 minus 1 2 minus 2. Okay, then b equal to set of 1 4 9. Okay, then the function f from a to b is defined by x square, that is f of x equal to x square. Here I can represent this function pictorially as let this be the set A and the other set B be this one, this be the B, then the elements be 1 minus 1 2 and minus 2. Here the elements were 1 4 and 9. So the relation is from A to B, and it is told that the f of x equal to x square, f of x equal to x square. So this can be x. Okay, so the function will be, or the image will be in the set B. So 1 square can be, this function can be plotted like this. Okay, 1 square is 1, and minus 1 square, minus the square of the minus 1 is also 1, so it can be plotted to here, and the square of 2, that is 4, and also that of minus 2, it is also 4. So from the figure it is clear, that a domain of the function is equal to minus 1 2 and minus 2, and the range of the function is 1 and 4. So codomain is 1 4 9. So what is the domain here? Domain will be equal to, the set A, that is 1 minus 1 2 and 2 minus 2. Okay, while the range will be equal to, I have shown here, f of x equal x element of A, that is the range. Okay, so here range will be this one, 1 and 4, the value of the function, the possible values of the function, that is 1 4, and that of here the codomain will be the set B. The codomain will be the set B itself. It's set B, that is containing 1 4 and 9. Okay, and now let's move for a problem. Find the domain and range of the function f of x equal to root of 9 minus x square. So we must find the domain and range of this function. So for doing this problem, we need to find the x for finding the domain, and by using the conditions here, and we should find the range by applying f of x equal to y, that is from that we will get the value of y, that is possible values of y, so we can find both the domain and the range of this function. So first of all, the function is f of x equal to root of 9 minus x square, and for the function to be defined, that is for real values, it must be the 9 minus x square must be greater than or equal to 0, otherwise it will be a complex root. So 9 minus x square here must be greater than or equal to 0. If we I don't like that my negative sign for this variable, so I am changing that sign, so that is x square minus 9. So whenever the sign is changed, the inequality also reverses like this. So x square minus 9 is less than or equal to 0. So that means that and we can write it as split into x plus 3 into x minus 3, into x minus 3, the x square minus 9, that's a plus b into a minus b. So we can write this x plus 3 as also like this, x minus 3, x minus 3 multiplied by x minus 3. Okay, oh don't worry, it's not formal to use like that. You can also write like this, x minus 3 of x plus 3, or anything which is less than or equal to 0. So now we can easily find the range of this value, or the value of the possible value of this x from this equation. That is, we know that uh, if a is if a is less than 0, a less than b, if a is less than b, from x minus a of x minus b is less than or equal to 0, then the value of x will be between a and a will be less than or equal to x, which will be less than or equal to b. Here the minus 3 is less than 3, that is in the place of a, that is minus 3, and in the place of b, that is 3. So we can write the value of x as minus 3 less than or equal to x less than or equal to 3. Okay, so that is the value of the x possible here. So domain will be, so we got the x value of x, that is the domain here. So domain will be, which implies domain is equal to, it can have the values from minus 3 to plus 3. So closed interval minus 3 to plus 3. So that's the domain. And now we need to find the range of the function. Okay, for that, let uh, f of x be f of x equal to y, and then we can write it as y equal to f of x is root of 9 minus x square, squaring on both sides we get y square equal to 9 minus x square, and from this we will get x square as x square equal to 9 minus y square. In the equation, in this equation, if you apply that one, that the value of x square in this equation, we let this be equation 1. If that if we apply that value of x square in this equation, then that equation 1 becomes equation 1 becomes 9 minus 9 minus, in the place of equation 1 was x square minus 9 is less than or equal to 0. So in the place of x square we can write a 9 minus y square. 9 minus y square minus 9 is less than or equal to 0. That means 9 gets cancelled, that is y square, changing the sign, y square is greater than or equal to 0. So that's the thing we got here. So y must be greater than or equal to 0. That's the thing here. And now we need to apply one more condition, that we know that and we know that the f of x is equal to root of 9 minus x square, right? 9 minus x square. So here, or from the from this equation, that is x square equal to 9 minus y square, let that be second equation. So we can write as x equal to root of 9 minus y square, and that means y square, 9 minus y square must be greater than or equal to 0, otherwise it will be is complex root, so it is not possible. So 9 minus y square must be greater than or equal to 0. So we can write the or change the sign. So y square minus 9 will be less than or equal to 0. From that we can write y minus 3 factorize, we get y minus 3 of y plus 3 is less than 0. So we can simply apply the rule I told before, that is if a is less than b, x minus a into x minus b is less than or equal to 0, then x will be minus a, or the a or a less than or equal to x less than or equal to b. So here minus 3 will be less than or equal to x will be sorry, y will be less than or equal to 3. So we got another one here, that is y is greater than or equal to 0. Y must be greater than or equal to 0 and should be minus 3, should be from minus 3. uh, y is between minus 3 and 3. So applying those two conditions, this y is greater than or equal to 0 and y is between minus 3 and 3. So the range or y will be equal to the interval, closed interval 0 3, closed interval 0 3. So that is the range is equal to, range will be that y, that is closed interval 0 3, closed interval 0 3. So that's the answer. So let's find the answer there. Minus 3 3 and 0 3, closed interval minus 3 3 and closed interval 0 3. So option A is the right answer. So option A is the right answer. What we did here was that we took the function f of x will be root of 9 minus x square and applied the condition here to root of 9 minus x square to be real. It must be greater than or equal to 0, otherwise it will be complex, and applied that root of 9 minus x square must be greater than or equal to 0, or I mean 9 minus the inside one, that is 9 minus x square is greater than or equal to 0. So and by applying that we found the value of x, and then we came to find the value of y by y, or range, by calling y equal to f of x and applied that equation, and from that we found the value of x square and applied that in equation 1 and simplified to get the value of y. So we got 1, and that was not over, so we applied another condition to that was from the equation 2, that was from the equation 2, this equation x square equal to 9 minus y square. So from that we took that x is greater than, x is equal to root of 9 minus x square, 9 minus y square, 9 minus yes, 9 minus y square, and we got that 9 minus y square is greater than or equal to 0, and applying those conditions, or simplifying, we got the value of y as this, that is between minus 3 and 3. So we got the final, that is y is equal to closed interval 0 3. And now moving to the next question. Let f equal to set 1 1, ordered pair 1 1, ordered pair 2 3, ordered pair 0 minus 1, ordered pair minus 1 minus 3 be a function from z to z defined by f of x equal to ax plus b for some integers a and b. Find a comma b. So let's do it. It's actually a simple question. We know that here the function is f equal to ordered pair 1 1, ordered pair 2 3, ordered pair 0 minus 1, and ordered pair minus 1 minus 1 minus 3, and we know that we have given that f of x equal to ax plus b. Otherwise we can call f of x as y equal to f of x. So we can write here y equal to ax plus b, ax plus b. So in the first case 1 1, the function is 1 1, so that is a b, a and b, a is equal to 1 and a, oh sorry, x equal to 1 and x equal to 1 and y equal to 1, x equal to 1 in the, from taking the first one, that is x equal to 1 and y equal to 1, applying that in this equation 1, or simply in this equation, that is we get 1 equal to a plus b, 1 equal to a plus b, that let that be the equation 1. And in the second function, or the second one, we get x equal to 2 and y equal to 3. you can simply apply that in the equation of function, because that is a function given here. So in the place of y we can apply 3, and 3 equal to a in or a of x, that is 2x, I mean 2a in the place of x, that is 2, and 2a plus b is nothing that the same one, and that is equation 2. So subtracting equation 1 from equation 2 we get, or the equation 2, separating equation 2, yes, separating equation 1 from the equation 2 we get that a equal to 2, and putting that value of a in equation 1 we get b equal to 1 minus 2, that is which implies b equal to minus 1. So we got a is equal to 2 and b is equal to minus 1. Let's look at the options here. So option B is the right answer. A is equal to 2 and B is equal to minus 1. So that was the answer. And to know more about the cloud vendor, visit our website. You can Google by typing cloud vendor Gaurish. Site appears as the first result, or simply search cloud vendor and you will get the site as the third result. And also you can follow us on different social media platforms, and you can follow us on Instagram, and you can follow on WhatsApp. I have created a WhatsApp group for discussions on different doubts you have, and the links are given in the description box. Also a Telegram group for discussion and the same purpose, and a channel is also formed for giving off your learning steps, and all the links are given in the description box. You can check it later. You can also ask your doubts as comments in YouTube, and if you want more videos which would be uploaded in the coming days, please subscribe our channel and press that bell icon for getting notifications on time.
Hope you guys understood the topic. Thanks for watching my video. Always be free to ask questions. Subscribe to my channel for more videos. If you like this video, share it with your friends. See you guys.